Hello everyone, I am Anushka Desai and I am from Team 1. We are working on the topic of Yelp database insights using a Cosmos multimodal database system. So our objective was to use the Cosmos multimodal system and design a robust database schema by using relational, graph, and document databases, but using entirely only the Cosmos architecture. So we have tried to analyze user reviews and ratings to understand consumer preferences and trends in the restaurant industry. We have also tried to study the relationship between restaurant attributes and customer satisfaction. We have identified popular restaurants in and top-rated establishments in certain regions. And we are utilizing graph-based models to analyze relationships between users and restaurants. For our project, we have also utilized Tableau to visualize restaurant data on maps to understand geographic patterns and concentration of dining establishments. So Yelp Open Data is found in the source of JSON files, which can be downloaded from the Yelp website. And we are storing these JSON files in the raw forms on the Azure Blob Storage portal. Now from the Azure Blob Storage, which will be our source for the raw data, we are using Azure Data Factory to transform the raw data into the corresponding SQL Server relational database and document and graph Cosmos DB. Then we are performing visualization and analysis from all of these three sources. This is the ER diagram for our combined model, which is including relational, document, and graph. As you can see, there are some interdependencies between all of these three. And this is our graph model where we are displaying the user and business relationships with the help of the reviews. Since users leave a review on a business, we are trying to model this relationship with our graph model, which we have done in the Azure Cosmos DB with the Gremlin API. I'm passing over to Ashish, who will be explaining our implementation process.
Hello everyone, I'm Ashish Shinde, and we are used 3 data layer for this project. The first one is raw data layer. So we are basically storing all the JSON files into Azure Blob Storage so that we all 4 team members can simultaneously have access to the data on the cloud. Then we are using ETL layer, in which we are using Azure Data Factory for pre-processing and data cleaning part. And our third and final layer is the foundation data layer, where we are injecting data from Azure Data Factory into Azure SQL database, Azure Cosmos DB for our document capabilities, and into Azure Gremlin for our graph containers. And in fourth part, we are using Tableau for our visualization. So this is just a screenshot of our raw data layer where we have loaded all the JSON file into our Azure Blob Storage. Here we are building a pipeline. So this is a pipeline execution screenshot for a business table. And this is the pipeline under the hood. So I will just quickly give an overview of this pipeline. So we have a check-in JSON data. And we are just deriving 3 columns from it into a derived column. And since we had multiple attributes in a single line, we needed it to separate it into various rows. So we have split it and then basically we have flattened the file. And then we are loading that data into our sink. This is the data execution pipeline for our user table, and this is the completion screenshot of the same. And this is, we are just checking if the data is loaded or not. So as you can see, the data is successfully loaded into the sink. This is the similar pipeline for our category table. And this is the review table data pipeline execution pipeline screenshot. And so thus far we have populated the data into our NoSQL Azure SQL database. Here we are loading the data into our Cosmos DB containers. So we have loaded business hours table into our Cosmos DB database. So this is execution screenshot of the same. And this is we have added our elite members table into Cosmos DB. Again, this is the under the hood pipeline for the same. And I will pass over to Ashish Pandey.
Hi everyone, Ashish Pandey here. So for the graph database, we are using a Gremlin API, and for that, and we are storing a business data in a business table, customer data in a customer user table, and the review in the review table. And also for this, we have assigned a weighted rank to each of the business. This weighted rank is assigned on the basis of the review count, how many reviews has been given to the business, and how many stars are given to that business. And based on that, we try to get a top 5 businesses based on the weighted rank. So this is the graph, and the vertices in the middle is the business, and all other vertices are the customer, and the edges between the customer and the business is the review given, and the edge between the customer is specify the friendship between the customer. So these are the top 5 businesses. And also we have implemented a schedule driven trigger for the user table, which get triggered after every 36 hours. So for visualization, I'll pass over to Mrinal.
Hi everyone, I'm Ranal and I'll be looking at the visualization. Oh, Tableau. Yes, so looking at the visualization for our database, we are using the data for Arizona state because Yelp data set was really huge and Arizona has the most number of businesses and also most number of reviewers are from Arizona. So we thought that let's take a subset of our data set, and that's why we chose Arizona. Now, looking at the number of reviews, number of businesses, and number of users, we can see that there are 284,000 reviews for 5,461 businesses, and we have almost 71,700 users from Arizona. We can also see that there's a gradual increase in the number of reviews, number of business over the years. So we can see that the restaurant business and Yelp has been increasing since the time they started. Then now that we saw Arizona, we'll just see how every city is doing. So yeah, if we see Phoenix is doing the best, it has almost 1,876 business belong to Phoenix itself, and followed by Scottsdale and then Tempe. So Phoenix has around 34% of all total businesses, they belong to Phoenix. And we have almost 50% users are from Phoenix as well. And 37.93% reviews are also from Phoenix. Followed by Scottsdale, we have almost 32% of users in Scottsdale, but only 12.54% businesses belong to Scottsdale. So we can see that we have users in Scottsdale. We also have like a good amount of reviews coming from them, but we do not really have that many restaurants for those users. So Scottsdale is a place where people can improve and people can put more restaurants, followed by Tempe as well. Again, 20% users are from Tempe, but only 8.7% businesses belong to Tempe. So these two are growing markets. Then talking about business category distribution, we can see overall in Arizona, we have
a large number of Mexican restaurants, fast food restaurants, American, Chinese, all of these restaurants. So they have a good distribution of categories available. And looking at the stars, almost 60% of the restaurants fall under 3.5 star rating or 4-star rating. And very minimal or very bad restaurants, or very like the best ones, 5-star rating is also very unusual. From this, we can understand the Arizona has a decent food rating, good quality of food, because most of them are 3.5 to 4 stars, which is a good review. Looking at customer experience, so at a glance, we have most of our ratings are fall under 4 stars, 3.5 stars, 4.5 stars. And for the ease of understanding whether a restaurant is good or bad, we have classified our data into 2 sets. First is bad or not so well. So if a restaurant is rated from 1 to 3 stars on an average, then it falls under not so well. But if it is rated from 3.5 to 5 stars, then it falls under a well-to-do or good restaurant. And as we can see here, most of whenever we have a review, there also is an upvote feature, a useful feature, or a funny feature for a review. So we can see that most of the 4-star reviews, 3.5-star reviews are found to be useful reviews rather than 2.5-star or 2-star reviews. Then we also have a distribution between members on Elite. One is non-elite and elite members. So we can see almost 94% of our users are non-elite, but 6% users are elite members. And from this we can understand that most of the impact which is made on Yelp is from these customers. Like elite members have almost 88% of fans, 71% of reviews, and also 86% of votes which are useful are from elite members. So good amount of contribution is done by elite members. So Yelp should rather focus on transferring these members to elite members to have a good review base. Now looking at attributes which belong to a restaurant and if they make the restaurant to be good performing or bad performing. First is Wi-Fi. We can see most of the restaurants before 2014, they do not have restaurants and they do not really matter. So 46.88% do not have a Wi-Fi in their restaurant, but they're performing really well, and followed by some of them which have free. So it doesn't really matter to people if there is Wi-Fi or there is no Wi-Fi. Also, then moving on to outdoor seating, we can see that let it be, if a restaurant has or does not have an outdoor seating, does not really matter for the restaurant to perform well. Almost similar number of users are performing good without an outdoor seating and with an outdoor seating. But similarly, if you look at alcohol, we have 65% businesses which do not perform that well, have no bar, but 70% of the businesses which perform well have a full bar, and 82% of them either serve beer or wine. So there's a difference of 10 to 15% if they serve alcohol or not. Similarly, for good for groups, restaurants which are good for groups are almost 10% higher, perform 10% higher than businesses which are not good for groups. Then looking at the delivery services, again, they do not matter. Even if the delivery services false or true, both of them almost have the same performance rate, which is 68%. But for waiter service, if they have a good waiter service, almost the number of businesses which perform well are more, almost 500 to 600 restaurants which have a waiter service perform well. Then takes reservations also shows a different, a slight variation based on if they take reservations or they do not take reservations. 47% restaurants do not take reservations and they perform well. That means probably people do not want to reserve in advance and they like the flexibility of having to just walk in. So those restaurants perform well, better than the others. Now, looking at the restaurant accessibility, we are seeing performance by range. Here we have, if a restaurant is pricey, that is $1 sign star, or $2, $3 or $4. We see that $3 and $4 restaurants are very minimum, and only 4% of them probably fall under extremely pricey restaurants, but most of them are budget friendly, and almost 60% restaurants, they perform well, be it like $1 star or $2 star. And similarly, but if we see reviews, we can see that restaurants which are $2 star have good reviews. 53% of the total reviews are good reviews, fall under restaurants which are $2 star. So you probably would want to choose $2 star restaurants over a $1 star restaurant. And the number of users which are rating are also more for the $2 star restaurants. These are some economical delights and affordable restaurants with good ratings. So, sorry. We have these restaurants which are performing really well and also have a price range which is either $1 or $2. And we can see famous restaurants like Panda Express, McDonald's, Buffalo Wild Wings, Chili's, all of them are doing really well. Then our last graph is for the, last graph is for the low price businesses by stars. So we have McDonald's, which have around 105 different locations spread out in different locations, like 105 different restaurants of McDonald's are present over the area, and they have a rating of 2.53 and 3.5 on an average. Similarly followed, we have 88 Subways, 52 Panda Express, 52 Jack in the Box, similarly, which are also like good rated. So these are some low priced business which you can find in different locations around Arizona. So this concludes our presentation. We have looked at Yelp insights, and we have used this data to find out which restaurants do well. So overall, we can find out that Arizona is a good place for dining. It has cheap options to dine, and it has variety of food, which ranges from Mexican, Italian, Chinese. And also some cities in Arizona are growing markets, and people should capitalize on that. Thank you so much. Anybody has questions?
Yeah. Hi guys, this is Shravya. That's a pretty good presentation in the first place. Good job. And I have one question, like how did you create a graph database basically from the CSV file? Is there any pipeline or?
Yeah, so actually it was we did it by Azure Data Factory. So basically we loaded the data into Azure Cosmos. And from there we used like a Gremlin API to form the vertices. So we basically utilized Gremlin query to structure to plot a graph with the vertices and edges. So once the data is loaded into Azure Cosmos DB, we just ran Gremlin queries to form the graph structure based upon our relations.
So for each row you have written a Gremlin query and then executed.
Yeah. So that's why we selected only just top 5 good performing businesses, so that we can write queries on that. Because our data set was large, so obviously we were like not capable to write the query for all the businesses. So we selected top 5 businesses, and then we plotted the graph.
Okay, yeah, that's all I had. Thank you.
Any other question or comment for team one? Okay, team one, I have a question for you. So you have 3 data models and you created a lot of very good reports and visualizations. What data models did you use for reporting and visualization purposes?
Hi, Professor. So we picked up mostly relational data models for our visualization, and most of our query tables were also in relational data models. And for others, we tried to write queries so we can get data in a relational format, and then we utilized that to create our presentation, like our visualization.
Okay, great. Yeah, your reports and visualizations look pretty good. Thank you.
Thank you, Professor.
Yeah, thank you for the great work and the presentation from team one, and thank you for the question. Excellent. And it's just a general question. I saw that team 3 and team 4, you all wrote some Python code and SQL code to implement your architecture. How about team one? Team one, did you need to write a lot of code for your implementation?
Professor, we only needed like the code to implement the Gremlin graph database, the creation and all. And we had written some basic SQL code for creating SQL databases.
And
for we have written like few queries to get the extracting subset of data for our visualization purpose.
great. So for your implementation, you used mostly you used the tool, right?
Yeah, mostly it's Azure Data Factory.
Excellent. Okay. Okay. I think those are 2 different approaches, but the industry trend is unless we need to write, we have to write code, we will try to use the tool. But I saw that you all have implemented your design very well, and you have all maximized the tools and the functionality provided by the environments. So that's excellent.